Hey everyone, Mr. Kaczynski here, dealing with IXL Z Algebra 1 skills, Section Z, polynomials, getting towards the end of it here. In my last lesson, I taught you how to multiply two binomials. Today we're going to do the same thing, but identify a couple special cases. First one of those cases is called the square of a binomial pattern. Okay, so if I'm going to square a binomial, something like this, I'm going to do a plus b squared. It's a binomial squared. All right, so if I do that, maybe I draw a rectangle diagram to show this pattern. So I've got a plus b squared means a plus b times a plus b. So what's the area of this portion of the rectangle? A by a, which is a squared. What about this portion? It's a tall and b wide, so that's ab. This portion is a wide and b tall, so a times b is ab, and this portion down here is a square that's b tall and b wide, so it's b squared. So a plus b squared equals a squared plus 2ab plus b squared. All right, now we can use that pattern to do all of these squares, okay? So v plus 3 squared. Basically, I do a squared, which in this case is v, so v squared is v squared. Then I do a times b and double it. So v times 3 would be 3v, doubled would be 6v. And then I do b squared. In this case, b is 3, so 3 squared is 9. And that's the idea, is it's supposed to be quick and easy, okay? Because in this square, we'd have v squared, 3v, 3v, and 9. Let's do this one down here. So 3k, we take the first term and we square it. 3k squared is 9k squared. So 3k times 3k. Then we do the two terms times each other and we double it. 3k times 2 would be 6k, so we'd have 6k in this box and 6k in this box. So we double that or add them together and we'd have 12k. And then the last box would be 2 squared, which is 4. All right, the only difference here is subtraction. I'll get to that in a second. So 3p squared, which is 3p times 3p, which would be 9p squared. These two boxes, the AB would be negative 12p. Negative 4 times 3p would be negative 12p. So negative 12p and negative 12p, or negative 12p doubled, would be negative 24p. And then we've got negative 4 times negative 4, which is positive 16. So that creates what we call a perfect square trinomial, because it can be written as the square of a binomial. So that's the square of a binomial pattern. And now we'll look at the sum and difference pattern. So the sum and difference pattern is when you have this, a minus b times a plus b. So let's draw that. Let's do it with a rectangle diagram, and we'll see what happens. A plus b here, it really doesn't matter what order we do it in, and a minus b right here. All right, upper left, notice we get a squared. Upper right, a times b is ab. Lower left, a times negative b is negative ab. And lower right, negative b times positive b is negative b squared. I want to do all these in a different color. So a squared, ab, negative ab, and negative b squared. Here's the key thing too, is that AB minus AB is nothing. So those just cancel out. And what are we left with? We are left with a squared minus b squared. So whenever you have a minus b times a plus b, kind of like this one, a minus b times a plus b, where a is x and b is 4, we can just write it as a squared minus b squared because the middle terms cancel out. You're going to have a positive 4x and a negative 4x that add up to nothing. So this is just x squared minus 16. Done. So instead of doubling the middle, the product of the two, they're actually canceling each other out. This one, a is 2m, so 2m squared, or 2m times 2m is 4m squared. And then b is 3, so we're going to do minus 3 squared, or minus 9, just 4m squared minus 9. And the last one, 4h plus 1 times 4h minus 1, 16h squared minus 1. 4h times 4h is 16h squared. 1 times 1 is 1. It's always subtraction. Always subtraction on these. So that's the two patterns. We got the sum and difference pattern, and we have the square of a binomial pattern. Those are the special cases or special patterns that we use to multiply two binomials.